Alright guys, so I'm in here inside, and plan is today is to work on figuring out how to create a power feed for the lathe. So this lathe, it comes equipped with a Acme lead screw, and the back gearing you can adjust to control your feed for doing threading and whatnot. But I would like to add a external electric motor onto the side so that I can control with more precision the exact feed, because a lot of the guys have talked about these Atlas lathes that they don't actually go slow enough. So I would like to add a fine control with an external motor that I can run and forward and reverse. That way, if I'm just doing regular turning, I can control it exactly the speed that I'd like. And I bought these small, I think they're like essentially a Hall effect sensor. So you have a sensor that you mount up, and then a magnet rides on whatever you're measuring, and then it sends feedback and tells you the exact RPM. So hopefully these work well, but my plan is to use these. I'm going to put one of these on the spindle of the lathe to monitor the spindle RPM, and then I'm also going to put one on the cross feed, I guess what you would call it, so that way I can monitor exactly how fast that I'm feeding in. So, well, not feeding in, but feeding across for turning. So I can't use it for threading, because for threading your feed side to side has to be linked to the headstock, that way that the threads match up at the same point. But I can use it for every other turning situation. That way I don't have to turn manually, because it's hard to get a good surface finish manually. But I did some research, and kind of what I think I'm going to do is I got a inverter here that'll run just regular 110, turns it into 12 volts DC, and then, well, actually you can, 12 volts at 10 amps, and then right here I have a pulse width modulator. So this works well with DC motors for speed control, because instead of like old sewing machines, they had basically a big resistor that you would have. It would lower the voltage coming in, but they generate a lot of heat, waste heat. They're not efficient, so, and you don't get the very fine control. But yeah, so I think this pulse width modulator will work good, because it essentially maintains peak voltage, but it breaks it into pieces, and then the duty cycle changes. So instead of giving full power through the cycle, it can chop it up, and that's how you slow down the speed, because it's not getting it gets bursts of power essentially, but it doesn't lower the voltage, so you're still getting pretty much maximum torque, at least from what I've read. I think that's essentially the gist of it. So it should theoretically control the speed of a DC motor well without dropping the voltage a ton and losing torque on the low end, because I'm going to have to be spinning this pretty slow. So I think that's what I'm going to use. This one says it's rated for 7 to 70 volts input, and then a max of 30 amps being put out. So we'll see. I don't know if that's true or not, but again, these are just some cheap components too I got off Amazon, so we'll see if they work. But I have two potential options for the motor, one of which is this old Dewalt Drill. I was doing a tree job for a guy, and he gave me this because I don't even think he had batteries for it. So it's just been laying around. I haven't used it. And these are geared, I don't know if this is a brushed DC motor or a brushless motor. I haven't looked at it yet. But these are reduced down quite a bit, so they're torquey, especially on the low end. So, and I don't know if this switch, sometimes the switches have variable speed control, but I haven't got into the meat of this thing, so I don't know if this has got variable control or not. But either way, I could modify. I mean, I don't know if this could have pulse width modulation potentially, but it's pretty old, so I don't know. So we'll see. I got to take it apart and see what's inside. But I might be able to steal the motor out of that. And then also I have this motor over here, and this motor was out of an electric lawnmower someone gave me, and I pulled the motor out, and this is an AC motor, but as you can see, there's brushes and a commutator in there. So this is what you call they call it universal motor. So essentially in these universal motors, they still have, they look like a brushed DC motor. They're still laminated steel plates, and they can function the same as a brushed DC motor, but they can also run on AC. And then usually, because like an AC, a three-phase motor is easy because the poles are all out of phase, so there's 3 windings essentially that are getting energized, and then they're spinning, so it's self-starting. But a single-phase motor, it has to have some sort of mechanism to start it, so it either has a main winding and then a starter winding that's essentially delayed with a capacitor, so then that allows the starter winding to be like almost slightly out of phase, and then it kicks over, and that's what it allows the motor to spin. Otherwise, if you had no starting winding or anything, that motor is just going to get energized and it'll just hum and it won't move. So yeah, so but on those motors, they have commutator like a DC motor, so you can actually run one of those universal motors on AC or DC. But that motor is pretty large, and honestly its lathe is so small that I don't think I need that much power to feed the cross lathe. I might be able to get away with a drill this size because the lathe is pretty small and it doesn't take a whole lot of force to make that carriage slide. So yeah, I'm going to dig into this, see what I can get out of it, see if that'll work, and then next, if this is too small, I'm going to switch over and maybe try that larger motor, or I might just order a small DC motor. But I just had some stuff laying around and I figured I'd dig into it. So, alright, let's get tearing into this guy. Alright, so now we're into the meat of the drill, and super simple. We've got the motor here. It's just a brushed DC motor, and then these 2 leads come down to the trigger here, which is connected right to the battery. It supplies with 18 volts, and then I believe this is just essentially a like a linear potentiometer, so it just controls the voltage. As the further you press down, you increase the voltage, decrease the resistance, and that's why there's this big copper heatsink. So yeah, nothing really fancy. That'll work for me. And then for speed, for switching direction, I think that is actually controlled inside of the chuck. So yeah, there's not a lot of electronics like some of the newer drills. This is an older drill, so it's super basic. So I think that this might work. But yeah, it's got a heavy magnet on it. See, again, I'm not sure exactly. I don't know if this will have enough power or not, but we'll play around with it. And if not, I'll at least get everything wired up to run this, and then if it's too small, then I'll probably just buy a large motor. But in this box here, so I've got just a regular project box. I plan on running, I want to run everything with those push button illuminated switches. So I got a big pile of relays here. These are just some cheap automotive relays, and they're just regular, like, power coming in. You have your 2 leads for the little electromagnet side, and then you have your power coming in, and then you have a normally open and a normally closed terminal. So these are super cheap. You can buy a whole bunch of them for nothing. And in the display box, I'm going to have, so in the display box right here, my plan is kind of to have like one, plan on just having 2 of these readouts stacked up somewhere, and then I'm going to have a series of switches that feed these relays, and then that'll allow me to have like one push button switch that powers on the spindle RPM, one push button switch that powers on the RPM of the crossfeed, and then I'll have one switch for forward and one switch for reverse that will allow that DC motor to turn forward and backward. And the way that I've figured out to do this, I got a little rough schematic here, but I think what I'll do is so you can see that on it. I'm going to just have this will be the positive. So essentially this is there's transformers over here, pulse width modulator, and then one lead feeding the motor, and then the rest is going to go into a relay. But instead of just having a single relay that's fed by a switch, there's going to be a series of probably 3 relays. So I know you could accomplish the same thing with a double pole, double throw switch, but I wanted to use the illuminate buttons, and all I had was these relays. So I'm going to use just the regular relays. But on the positive side, there will be a first relay that's set normally closed, and then it runs down to another relay that is normally closed that feeds the positive end. And then the negative side will be running it normally closed, hooked to the negative side. And then also we open, or hooked to this negative open side. So when nothing is happening, there's no power, when you engage the first push button that actuates this relay, that will close this contact, feed power down to the normally closed side, which will power the positive side. And then it will also push power this way to the normally open side, which nothing will happen. And then this negative lead will be connected to the normally closed, and the normally open, nothing happens, and then the negative goes here. So when this relay is activated on its own, power will feed that motor. And then if you want to reverse it, you deactivate this relay, and then you activate this second set down here. So then we'll now make this negative. And then over here, this will switch to normally open, which will then allow power to come from here down into the normally open side. And then you have to power on the forward circuit again. So essentially this will just be, you have to turn this on, press reverse, and then hit this again, and then that'll make sure that you're not back flushing power during that time change. Because if this was left powered on and then you power this here, then you could potentially flush voltage back and then it'll short out. But if you click this on and off in between times, then you should be able to do it. So that's kind of the plan there. I know it's a little bit crude because of just using these regular single lead relays, but I think it'll work, at least for now, and then I get to use those nice illuminated switches. So that's the plan there. We got 120 volts coming in, 12 volts coming out of the transformer, feeding the pulse width modulator here, and then we have our large universal motor that we're running on DC. So that's running. So, and we've got variable speed control. We can switch directions, we change polarity. Speed up, slow down. The problem is at the low end, I can stop it with my fingers. And at the high end, it's probably going to be too fast on the spindle anyways. So our proof of concept works. We can feed this larger universal motor or AC commutator motor with a pulse width modulator and get variable speed control, but we're only feeding it with 12 volts, and this thing can handle up to 70 volts. So I really think what needs to happen now is we need to just get a transformer that's got a higher voltage that it puts out. That way we can really feed this thing what it needs. So I think that ought to work, and then yeah, maybe we will mount this guy up. It's a little large, but I don't know, we'll see. I'm gonna look online, maybe look at some motors, see if I can find some 12 volt ones that are still can put out some power, that are a little bit larger. But yeah, gotta look up a few things, do a little more work. I'm gonna start working on this panel though. Either way, I can wire this panel up to feed all these gadgets here, and at least get the spindle speed and crossfeed sensors hooked up, which would be useful for turning for now. And then I'll look more into what to do about this motor and maybe a different transformer that's got a little more juice. So, welcome back to the shop. Got some cool stuff I'm working on today. I didn't really show a lot. Build my control panel here for the lathe. just because the wiring's pretty complicated, and if you're gonna probably get into something like that, you're gonna have your own plan and your own kind of wiring experience, and it's kind of hard to explain the thought process, but I'll walk you guys through it a little bit and show you kind of what I did. And essentially, here, let me grab the panel. So here's the control panel I was working on. So what we got here is this is the RPM readout for the spindle. This is going to be the RPM readout for the lead screw for the carriage feed. And then also down here we have a forward and reverse function and a pulse width modulated controller that is going to run a DC motor on the end of the lead screw. That way I don't have to mess around with changing out the back gears if I want to change my carriage feed speed. So in normal turning operations, I can just kind of dial in the speed I like, depending on how the cutting tool is working and everything else. So it'll give me a lot finer control. And then the only times that I would use the back gearing in the lathe for the lead screw was going to be during threading, because you have to, because the headstock has to be synced. But other than that, I think this will be super handy. So I'll open this up, give you guys a little look, kind of explain briefly what I did and how these sensors work and how cheap this whole thing was. Alright guys, so this is the panel here. Like I said, we have our RPM readout for our spindle and our carriage feed, as well as we have on and off control, or forward and reverse control, and variable speed for the carriage lead screw. So taking a look in here, yeah, I know it's a little bit of rat's nest. I was trying to get this done as fast as I could, but that aside, kind of what we got going on is this down here is our power supply. So we're having our regular 120 AC coming into here. I tested it over on the bench, but I have to hook up a cord. But anyway, so that runs in here, and then we have our grounding pins coming up to here. This is our ground bar, and then I just picked up a cheap one because I needed one after I started this, and it didn't have all the pins connected, so I put some little copper jumpers, just some 12-2 wire. And then this is our this is the positive board here, and then this is kind of where I pulled off a lot of the power feeds. And so this thing puts out 12 volts. It just transforms 120 into 12 volts DC, 120 AC to 12 volts DC, a max of 10 amps, which is totally fine for this project. And each of these switches here, the reason why they have 4 wires is because there's LEDs, and you kind of have to power the LEDs to illuminate the switches. They have to go wherever the destination of the switch is, and which these head down to the these are just 12 volt regular automotive relays, just normally open or normally closed. So there's 2 wires coming in to power the coil of the relay, and then we have our input power. Or actually, sorry, this is input coming in, this is output, and this is power to the coil, and this is ground, and that's wired. There's 2 on this side, 3 on this side, and then up here is the pulse width modulator. So this is where things get a little funky, because these readouts here, these were pretty simple. The sensors are over here. I just wired them out the side, and they come with these little magnets, and every time you mount the magnet to whatever you need to measure the RPM of, and as the magnet crosses, it's like a Hall effect sensor, every time it crosses, that sends a signal into the controller, and then it can decode the speed of whatever it is. So, and these were cheap. They were like 20 bucks each on Amazon, so I don't know if they're super accurate or not. I have a little laser tachometer, so I'll check them with these to see. Again, not even sure of the accuracy of this thing, but it seems pretty repeatable, so I'll check it against that. And then each of these switches powers on these, and then down here things got a little complicated because I only had single pole relays, and in order to add power forward and reverse, I had to have 3 relays and arrange them in kind of a strange pattern to essentially make a double pole, double throw switch. I won't go super in depth into that, but if you sit down and draw it out, you can figure out how to make a double pole, double throw switch. And this is just stuff I had, so I used these. I could have got a different relay or whatever, but I just used what I had. So it worked out. And then coming out here, this is power to the motor, and this pulse width modulator is powered. We have power coming in, and then it feeds out your power that is pulse width modulated to these switches, which then feed the relays, and then in a series of relays that are wired differently, we can get forward and reverse just from 3 single pole relays. But again, I'm not going to go super in depth on that because I'd have to draw a diagram and it's a little confusing. But yeah, it works pretty slick. Let me get this thing. I got to get the power. I cut an old cord off of a broken electric stapler or something, so I'm going to get that power cord in here. And I just used a regular wire clamp like you'd put in the end of an electrical box, just a 1/2 inch clamp. So I'm going to run that through here, and then I'll show you the motor I'm using and kind of how all this is going to tie into the lathe. So let me get that hooked up, and then we'll get hopefully some power and some lights. Alright guys, so I got the power cord in here, and I'm going to hook this thing up and show you how it works. Okay, so green light down there tells us we're getting power to the little transformer. We got it set to run on the pulse width modulator, which we also have a power light there. And then let me grab the motor. So this motor here, this is a power window motor of an old car. We got a couple old cars here on the farm, and I just ripped this out of it. I also pulled out, I really pulled out every motor I could find in the car. I pulled out a windshield washer motor, but the case was cracked. I think this one would have been ideal because there was already a threaded shaft, but this has a lot of torque and it's about the right size, and I'm going to go dick around with getting another motor out of another car, so I just let that one go. Here's another one that I broke it getting it out. A little too much action with the screwdriver that's never actually a screwdriver but a pry bar. So yeah, that one got broke in the process. And then I pulled out several of these power seat motors, but they were kind of too small, and they had this flexible square drive like what you would find in a weed whacker that has like a bent neck. So I figured that was kind of too small. So I ended up settling on this guy. The only thing is this pin is pressed in, so I have to, the gear rotates because it's connected with teeth into this here. This like little shock absorber, kind of like in a log splitter hydraulic motor coupling. But anyway, so yeah, the shaft doesn't spin, so I can't turn the shaft, but I pulled the gear off the other one, and I'm going to turn a shaft, press it in, and then mount it to a threaded coupler on the lathe, but I'll get into that in just a second. So I want to set this motor up so you guys can see it. And again, all those motors that you're going to find inside of a car, they're all DC motors. So old junk cars are a really great resource for old DC motors. And if you don't have any junk cars, I'm sure you could go to a junkyard and pull these for next to nothing. So right here we click that. That is our RPM sensor right here. It's got power to it. That's going to be on the spindle. Our next RPM sensor is right here. That is for the feed rate. And then this button here, that gives us motor power. And notice it is rotating counterclockwise. So when I kill power, initiate the reverse switch, and reconnect power, now we're rotating clockwise. And then with the pulse width modulator, we can crank up the speed. And this is about 67 RPM here. And we can turn it all the way down to a crawl. And it's still got torque at a crawl. I mean, I can still not hold on to that. So yeah, it's still pretty torquey. So I think it'll work really nice for that lead screw.